Okay, students, after successful completion of our ethers one shot lecture already completed and already video is uploaded in our YouTube. Okay, so I think all of you have gone through that. Definitely it is going to affect your score within the short span of time, right from the basic examples to the advanced example like oxygenanes, epoxides also we are able to cover with the same spirit and same josh. We are going to start the aldehydes. Okay, so let's start with the aldehydes chapter. Understood? Here also we will be doing same. We will start from the very basic as if you are not knowing anything, and I will try to explain in the board point of view, mains point of view, NEET point of view, so that no exam should be unattended. Okay, so let's start with aldehyde and aldehydes. Okay. Okay, here we see aldehyde and ketones. Both are studied together. What is the reason behind and what is the common thing that I am going to explain from the basics. Definition of aldehyde and ketone. Definition of what? Aldehyde and ketone. Okay. Actually, they both have the same general formula. What? That's why they are started and studied together. And they have same common group that is called as a carbonyl group. Okay, many students, when anybody asks what is the functional group like this, okay, normally they will answer as it is ketone. No, it is not ketone. It can be aldehyde or it can be ketone, even it can be carboxylic acid, even it can be amide, even it can be acid chloride. Okay, actually this is called as a carbonyl group. What group? Carbonyl group. Okay, so what are aldehyde and ketones? Any substance having general formula of CnH2nO, okay, are called as aldehyde or ketones. Actually, they both share the same common general formula. Okay, and aldehyde and ketone are collectively called as. Suppose one fine day you are not aware that whether it is aldehyde or ketone, then simply call it as a carbonyl group. Okay, so what is carbonyl group? Carbon is a tetravalent. Carbon is tetravalent in which each carbon is attached to two single bonds with, it can be alkyl group or it can be hydrogen, but one double bond with the oxygen is must. Okay, so this is the first introduction to the carbonyl group or aldehyde. Okay, so I think all of you are having clear concept now. Let's move on to the next one. Okay. So next, what does the next slide says? This is what the aldehyde carbonyl group is linked. The difference between the aldehyde and ketone, it is explained. In aldehyde, it is linked to one hydrogen atom. Okay, this is must, and two is very super. Okay, at least one hydrogen is must. If both are hydrogen, then it is called as a formaldehyde. Okay, so but at least one hydrogen is must. The other can be alkyl group or other can be aryl group. Other can be what? Aryl group. Aryl group in the sense it can be benzene and derivative. Is it understood? Aldehydes are carbonyl group linked to one alkyl or aryl group and one hydrogen. Okay, but aldehyde is a monovalent. Monovalent means CHO can form only one bond. One means mono. Valent means bond. Okay. CHO aldehyde is a monovalent and terminating group. It always found at the last of the functional chain. It always found at the last of the functional chain. Okay. So this lecture is going to be very fast. So try to be attentive. In the first, what you have to do, understand the concept. After that, what you will do, again come back to the video lecture, then take screenshots and write notes properly. Okay, because your notes are only the thing which is going to selecting factor. Okay, then in aldehyde, carbonyl group is joined to two alkyl group and two aryl group, or one alkyl or aryl group. Understood? Simply you will remember for the time being, Aldehyde is a monovalent, only one bond it can form, and it always available at the end of the chain. Okay. Now let us see the next one. Let us see the next slide, which is about the classification. Okay, so this is the most important and explained with the clear formulas. Okay, if two groups of the attached to the carbonyl group are same, then they are called as a simple ketones. They are called as what? Simple ketones. Okay, then if they are different, then they are called as a mixed ketone. See, here it is R and here it is R dash. Therefore, it is called as what? Mixed ketone. Here also R and here also R. Then it is called as a simple ketone. And here it is R and here it is hydrogen. Then it is a aldehyde. Okay. So it can be R or it can be aromatic. It can be even aromatic also, no problem. So classification of carbonyl compounds. Carbonyl compounds are divided into two types, aldehyde and ketone. Ketone are further divided into two types, simple ketone and mixed ketone. I think up to here it is clear now. Okay, now let's see the next one. Okay, structure and hybridization. Like we have done similarly in the ethers also. In the ether, but we have seen the structure of the oxygen. With respect to oxygen, we have seen R and R dash. Here, that was sp3 hybridized. But here we have to see the hybridization of, what? Carbon only. Okay. So in the carbonyl group is the main thing here. In this one, carbonyl group is the main criteria. Okay, this is the carbonyl group, and in this carbonyl group, and here carbon is attached with the total four groups: one, two, three sigma bond and one pi bond. Already I told you the trick. What is the trick? Number of sigma bond plus lone pair. So here number of sigma bonds are how many? 3. Lone pair are how many? 0. Therefore, total 3 plus 0 answer will be 3. So answer 3 means hybridization will be sp2 hybridization. Okay. Don't reveal this shortcut to anybody. Understood? Okay. This is very top secret shortcut. sp2 hybridization. So how we got sp2 hybridization, is it understood? So it will form 3 sigma bonds. It will form 3 sigma bonds. Okay. And once it is sp2 hybridized, it will be 120 bond angle. And shape is a triangular planar. Triangular planar. This is about the structure and hybridization of carbon. Is it understood? In the aldehyde, or it can be ketone also. Okay, now we are going to have collection of the common name. Actually, there is no problem with the IUPAC name because IUPAC name have some logic. Okay, so it is easy to write the IUPAC name, but it is it is difficult to write the common name. See, formaldehyde. What is the logic in that? But here in the IUPAC name, meth means one carbon, AN means single bond, AL means aldehyde. So there is a logic. One carbon is there, therefore meth, single bond is there, AN, and aldehyde is there, L. So methanol. Okay. What is the answer? Methanol. But there is no logic here. Formaldehyde. But you can create a logic wherever you find a word like pharma. That means one carbon. Aceta. That means how many carbon? Very good. That means there are two carbon atoms. Propio. Propio was old times it was used. It was used for three carbons. Okay. So lot of IUPAC in name collections we have, but don't write it now. Afterwards you will write it. Okay. Isobutyraldehyde, valeraldehyde. These are the very important. Therefore, what I will do, I will put a stamp on it. Okay. So stamp here, stamp here, stamp here, stamp here. Okay. So pharma is mostly used and most of the people are known. But valeraldehyde, isobutyraldehyde, one few more is yet to come. Okay. So this noting down, you will do it afterwards. You will memorize by writing 2 to 3 times. Okay. Okay. Now let's see the next one. Next also common names only. Acrolein, crotonaldehyde. These are the very important. Okay. So wherever it is important, normally what we have to do? We have to memorize that. Okay. Crotonaldehyde is important. Acrolein is important. Okay. Methyl valeraldehyde. These are all not much important, but there are chances. Okay. Here total 5 carbon atoms are there. Therefore, it is called as a valeraldehyde. But on that, methyl group is also there. Okay. So 3-methyl valeraldehyde. Understood? Actually, IUPAC name is simply 3-methyl pentanal. What is the IUPAC name? 3-methyl pentanal is not a problem, not an issue. Acrolein, commercially important compound. Commercially important compound. Crotonaldehyde, commercially important compound. Okay. So never and ever forget it. Understood? So 2-butynyl. Actually, double bond is available at the second carbon. 1, 2, 3, 4. That's why it is called as a 2-butynyl. Benzaldehyde is nowadays also it is used. But as per IUPAC, benzene carbaldehyde. What is the name? Benzene carbaldehyde. Okay. Next, cyclohexane carbaldehyde. Cyclohexane carbaldehyde. Both are same in the common name also, IUPAC name also. Wherever I am putting the star mark, that means either they were already asked in the examination or they are going to ask in your examination. Okay. So let's see the next slide. Now see p-nitrobenzaldehyde, very important. Phthalaldehyde is super important. Okay. So I will try to put actually this is phthalic acid is important, and nowadays it may be converted into aldehyde, phthalic acid, terephthallic acid, and there you will study in some mechanism also. Okay. So here bromobutyraldehyde not much important. Okay. As it is on the third, you can write it as a 3-bromobutyraldehyde. Now same way there is a exception. There is an exception in the naming as per the IUPAC. See here, these are not counted in the word root. See here, is it propane? That means only these 3 carbons are counted in the main chain. Why? Because if I count this and this, then it will be pentane. So, but this will be missing. So, when all are same functional groups, and if one of them are missing from the actual chain, then what you will do, you will write all of them as a suffix only, but carbaldehyde. Normally what we will write? We will write it as a aldehyde, but here we will write it as a carbaldehyde. Okay. So same way propane 1, 2, 3 tricarbaldehyde. Okay. In this chart, phthalaldehyde is important. Previous one crotonaldehyde is important. Likewise, whatever the important I am suggesting, I think that before revision you will go through that. Okay. Okay, here are some more examples. All these examples you will write in your notebook neat and clean. Okay, so this is actually hydroxycyclopentane carbaldehyde. This we have studied in our IUPAC name also, when sometimes functional group could not be included in the chain. Then we will use carbaldehyde. Okay, so here it will be 1, 2. Okay, 2-hydroxy carbaldehyde. Okay, cyclopentane carbaldehyde. Same way here it is a functional group. This is the main chain and this is a substitute. Okay, so it will be 3-methoxypropionaldehyde. In the common name it is propionaldehyde. In the IUPAC name it is propanol. Okay, next here 2 functional groups are there. When 2 functional groups are there, then what we have to do? We have to select the minimum functional group. Okay, functional group with the minimum possible priority is OH. So it is written as a prefix. So 1, 2, 3, 4. Okay, so 2-hydroxy butyraldehyde. But in IUPAC name, it is butanol. It is butanol. Okay. Now let's see the next question. Next slide, sorry. Okay. Now question, there is a question in the board exam. In the board exam, why aldehydes are ketone or why carbonyl group containing functional groups are polar. What is the, this is 1 or 2 marks question. Okay. So we will try to solve some questions also if possible. Okay. But that depends upon your motivation. How you can motivate me? Just by giving likes, shares. Okay. So here polar means positive and negative charge. Positive and negative charge must be there. Okay. How it is possible positive and negative charge? Here out of the sigma and pi bond. Okay. So there is a pi bond between the carbon and oxygen. Pi bond is the weaker most bond. So this is the carbon electron, this is the oxygen electron. Both will be shifted onto the oxygen. So because of that, after this what happens? There will be electrons density will be increasing on the oxygen. Initially before this process only already oxygen will have the 6 electrons. Okay. Now but when this electron also comes over here, okay, then there will be how many electrons? 7 electrons will be there with negative charge. Carbon earlier it used to have how many? 4 electrons. But after this transformation, this will be positive charge. It will contain only and only how many electrons? 3 electrons. Okay. So this is called as a carbocation. Carbocation, and this will be used in the nucleophilic addition. Okay, where you will be using nucleophilic addition reaction. Nucleophilic addition reaction. Okay, so this is the reason behind the polarity. Why carbonyl compounds are polar? Okay, polar due to high electronegativity of oxygen, in during which pi bond will be broken and given to the oxygen in the form of the lone pair. In the form of what? Lone pair. I think it is clear now with the diagram. Okay, now let's see the next slide. Isomerism in aldehyde and ketones. Okay, aldehyde and ketones. See, all of you, every time we will try to give you the shortcuts. Okay, so it is a super trick, ready-made super trick. Okay, so this way, if you remember this table, plenty of question you can directly answer. Okay, now first let us start about the aldehyde specially. Okay, so in this lecture we are trying to focus on the aldehyde. Aldehyde shows which of the following isomerism. In the advance, if it is given more than one correct, aldehyde show the chain isomerism. Okay, functional isomerism and tautomerism. This is about the aldehyde. But ketone can also show chain isomerism. Position is not possible in aldehyde. Why? Because we will say why aldehyde does not show position isomerism, but ketone shows the position isomerism. So here aldehyde can show the chain isomerism but not position isomerism because it is a terminal functional group. Aldehydes are what? Terminal functional groups. Okay. It will always available either first carbon or last carbon. But ketone is non-terminal. So its position can change from anywhere to anywhere. Therefore, it can show the position isomerism. Functional isomerism, metamerism. Metamerism is shown by the only polyvalent. Okay. So about all structural isomerism, we have one lecture. Okay. Isomerism in one shot. Isomerism in one shot. Go through that, then you will come to know which isomerism when you have to apply. Okay. The tricks you will come to know. Understood? So tautomerism, what is tautomerism, what is metamerism, this basic idea you should have. If you already have it, then it is very good. Okay. So here chain isomerism. Chain isomers of the aldehydes. Minimum number of carbon atoms required for chain isomers are 4. Okay. And in the ketone it is 5. Because these questions are already asked in the examination. Understood? Position isomerism already I told you it cannot be shown by aldehyde. But to show the position isomerism, ketone from pentanone only it will start. Functional isomerism even 2 also okay, but here it will be 3 carbon atoms are required. Metamerism it cannot show because it is non-terminal. Okay. And ketone is always terminal, therefore it can show metamerism provided it should be where it should be. It should have the 5 carbon atoms. Tautomerism it can show 2 with the 3 carbon atoms. Actually, ketone start with only 3 carbon atom. You cannot imagine a ketone with less than 3 carbon because ketone is a non-terminal. So 1 carbon required here, 1 carbon required here. Total will be how many? 3 carbon will be always there. 3 carbon will be always there. Is that clear to all of you? Okay, now let's see the next. So these tricks I think you all will note down afterwards. Now let's see some properties. Okay, let's see some properties. So in the properties, most neglected portion is physical properties. Most neglected portion is what? Physical properties, but they are focusing nowadays on the physical properties also. So let us go as per the current examination pattern. Okay. So here physical properties. Formaldehyde is only the gas. Formaldehyde means it is HCHO. Okay. Only the gas are next to 10 members. That is from acetaldehyde. That is from acetaldehyde to further. They are volatile liquids. Volatile means it can evaporate in the liquid form and colorless. Okay. But ketones even up to 11 carbon atoms are liquids. There is no gas in the ketone because it starts with the 3 carbon atoms only and higher members are solids. Okay. So this is about the physical state. Understood? So the question may be related to what? Formaldehyde. Question may be related to formaldehyde. Then coming to the solubility. These are miscible in organic solvent. So don't worry about the miscible. Miscible means mix. It can mix in the organic solvents like benzene, ether and chloroform. Benzene, ether and chloroform. How many of you are aware about the formula of chloroform? How many of you are aware about the chloroform formula? Who can guess? Okay, formula of the chloroform is CHCl3. Okay, what is the formula? CHCl3. It is a solvent, organic solvent. These are the some examples of organic solvents. What are those? Benzene, ether and chloroform, and kerosene also sometimes it is used. Okay, so proper in the solvents. Okay, organic solvents like benzene, ether and chloroform are the some examples of the organic solvent in which our aldehyde will be soluble. Okay, lower members containing up to 4 carbon, that is butanol, are soluble even in water also due to hydrogen bond with water. Okay, see this is the C double bond O and hydrogen, and this will form hydrogen bond with the water molecule. Hydrogen bond with what? Water molecule. Okay, so this can be possible up to the 4 carbon atoms. Therefore, once wherever intermolecular hydrogen bonding is possible, there what it will do? It will be soluble. Okay, but as the number of carbon atom increases, aldehyde and solubility ketone decreases. Solubility is inversely proportional to mass. Solubility is what? Inversely proportional to mass. So higher the mass, less will be the solubility. Lower the mass, higher will be the solubility. Okay. Now next, order. Order means smell. Don't worry about the wording. I will explain in the easiest possible way. So smell. Okay. Lower aldehydes have unpleasant, sharp, pungent. Pungent means you cannot stay there for a longer time. Okay. So that is called as a pungent smell. Unpleasant means you are not comfortable. Okay. So as the number of carbon atom increases, order becomes less pungent. Actually, it is because of the small size, small mass, it will move very fast. That's why it is sharp and pungent. Once the mass becomes more, then the spreading will be very slow. Therefore, it will become less pungent and more fragrant. Fragrant means it is best to inhale. Okay, hence they are used as a blending in the perfumes and flavoring agents. Okay, so always nowadays everything is flavor only. Flavor is not original. Okay, so like flavor is only that flavors are given by chemicals. Okay, so before taking anything you should ask whether it is original or flavor. Okay, vanilla flavor, chocolate flavor. So chocolate flavor does not mean that chocolate is available. Chocolate smell is given by the aldehyde. Acetone is an inflammable liquid. Inflammable means it catches fire very fast. Inflammable. Is it understood? Okay, next is about the boiling points. Next is about what? Boiling points. Aldehyde and ketones have higher boiling points. Reason. This is a 1 mark reason question. Higher boiling point than the ethers and alkane due to more dipole. This is what I have told you, polar nature. Reason also I told you. Okay. In this carbonyl group will be there. This carbonyl group pi bond will be shifted other side. This will be negative and positive. There is no such chance in case of the alcohols. There is no such chance in case of the ethers. Okay. So because of the more dipole-dipole interactions, they have higher melting and boiling points. Okay. Then carbonyl compounds have lower boiling points than of alcohols of comparable masses due to absence of intermolecular. Okay. Intramolecular, sorry, alkanes. Okay, so in alcohols there will be intramolecular hydrogen bonding will be there. So this is one alcohol, this is another alcohol. So between the two alcohols there may be hydrogen bond possible. Okay, so here I am writing the series. Alcohols will have the higher boiling point, then aldehyde or ketone. Okay, then ether, then alkanes or hydrocarbons. Okay, so higher boiling point will be of the alcohol, second highest will be of aldehyde or ketones, third highest will be of the ether, lowest will be of the hydrocarbons. Okay. Okay, next is about the boiling point examples. Okay, see here, alcohol, then ketone, aldehyde. Okay, so even in ketone and aldehyde also there is a change in the boiling point. Ketone is having higher boiling point than the aldehyde, then ether, then hydrocarbon. Okay, so boiling point is order of. This is the same example: propanol, butanol, butanaldehyde, and ether and butane. Okay, same way some more examples are like this: alcohol, aldehyde, ether and alkane. I think it is clear now. Okay, now next let us see the next one. Preparation methods. Next topic we have we have completed isomerism, we have completed IUPAC naming and including some famous, useful, most frequently asked commercial names also we have done. Okay, including the structure, including the hybridization we have done. Now we are on to the preparation methods. Okay, so in the preparation methods, first one is by the primary alcohols partial oxidation, because complete oxidation will give you, see if this word is missing, it can give you the other products. Okay, in the partial oxidation only aldehyde will be formed. Okay, so actually this will be CHO, so this hydrogen will not be there. It's a print mistake. Okay, so partial oxidation, in the partial oxidation, so this H2O will be eliminated and there will be double bond between them. Okay, so what we can write it as a RCHO. For partial oxidation, what we have to do, we have to use PCC, pyridinium chlorochromate. I want that everybody in the in some lecture I will ask people about the PCC formula. So that time you should be able to answer. Then PDC, pyridinium dichromate. Pyridinium dichromate. This formula also very important. And PCC got some special characteristic. PCC got some special characteristic. What is that special characteristic? It does not attack on the double bond present in alcohols. Okay, this is called as a selective oxidation. In the advanced examination, they will use word they will use selective oxidation without disturbing the double bond. If you want to oxidize only alcohols, if you wanted to oxidize only alcohol, the best reagent is PCC, pyridinium chlorochromate. Okay, formula, and Collins reagent. Okay, with the same number. So there are in the conversions, one fine day I will give you the conversions, because in the board exam there will be definitely questions of the conversions, butane to butanol, like that conversions will be there. I will give you excellent shortcut procedure where you can convert from hydrocarbon to nitrogen containing. All are possible. Okay, how to do that magic, let's wait. Understood? So in this one, PDC, PCC are very important. Now let's go to the next one. By dehydrogenation, organic people say that very difficult. But if you study technically, everything you will find it either on the arrow or in the heading. Okay. D means removal. Hydrogenation means hydrogen must be removed. So see here, very simple. What I will do, one hydrogen I will remove from here, one hydrogen I will remove from here. Okay, so this RCHO, as already I told you, you should be like Bahubali to cut down. See, tuck, tuck. So then it will give you the aldehyde. Okay, so for such dehydrogenation, specialist reagents are copper and silver. Okay, so our copper silver at 300 degrees Celsius, or copper silver in the air. Okay, this method is best for volatile alcohols, because air is also volatile. Automatically reactions will be carried out. Okay, so second method, first one is the partial oxidation. If partial word is not there or complete word is there, they will prepare the carboxylic acid in place of the aldehyde. Do you understand the importance of each and every wording? Here 300 degrees Celsius will be very important. What is important? 300 degrees Celsius. This is going to be one fine day integer type question. Okay, now let's go to the next one. By dry distillation of calcium salts. Okay, calcium salt, this we will do in the, specially this requires a practice. Which requires practice, that I will tell you and how it is, that I will tell you in the practice session very clearly. Okay, how it should be very clearly, how to memorize this, how to memorize this. Okay, so these all questions will be answered in the question session. I hope you all will actively participate, watch it in the question session. Okay, so this method is not suitable for the preparation of aldehyde except formaldehyde. Okay, because we get mixture of carbonyl compounds, we don't get one carbonyl compound. Okay, so here RCOO whole twice, this is called as a calcium salt. Okay, so anyhow I will write the structure here. This is the structure of the carboxylic acid salt. Okay. Now, when it is dry distillated, see cutting, how to cut down. Here one should be, sorry, formaldehyde. Okay. So, if I cut down like this, CaCO3. What is this? CaCO3. So, what is left over here? Here hydrogen is left over, here carbon, and here hydrogen. So this is only the product we are getting. That's why formaldehyde, it is best method. But what happens if it is other than the formaldehyde? One alkyl group is attached here. That time it will be very difficult. Understood? So it will give some ketone will be there, some aldehyde will be there. So don't take that risk now. Understood? So to avoid that, this is purely used for the formaldehyde preparation method only. Okay. Okay, then by the reduction of carboxylic acid, actually reduction means removal of oxygen. So this is a carboxylic acid. Okay, so this is a carboxylic acid. When you remove H2O and CO2, see it is CO2 and H2O. Okay, and H2O. This oxygen and hydrogen, H2O are removed. Then aldehyde will be formed. Understood? Same way formic acid. Formic acid is must. And one more thing you have to remember, there will be number of carbon atoms in aldehyde or ketone formed is equal to sum of the carbon atoms in 2 moles of acid. Okay? So here -1. Okay, so is not equal to actually. So here one carbon atom will be removed as a CO2. One carbon atom will be removed as a CO2. So by the reduction of carbonyl here, reagent is very important. MnO2 at 300 degrees Celsius. Whenever on the reactant side, if you find carboxylic acid and on arrow it is CO2, definitely you should remember that it should be an aldehyde. Okay, and more practice required in the calcium carbonate, calcium salts of the carboxylic acid. Okay, so I think you will do that. Now next special method, Wacker's process. Why I am calling this special method? Because you have already studied in your hydrocarbon alkenes. Okay, alkenes method is the best and special method. It is used as the PdCl2 and H2O. In place of the PdCl2, you can use CuCl2 also, CdCl2 also. And here if I am taking the ethene, what I am getting? Acetaldehyde. I am getting acetaldehyde. Okay. So frankly speaking, and as a shortcut, I will tell you here mechanism with the simple method. CH2, here water, how you will write? HCHO. Understood? So then what you will write? You will write oxygen, CH3. Then oxygen only will go here. This double bond will be single bond. Okay. So this hydrogen and this chlorine. Chlorine either is this chlorine or this chlorine or this chlorine. H2 plus Cl2 will be 2HCl. Okay. So that metal will be now alone. If you use PdCl2, you will get PD metal. If you use CuCl2, you will get Cu. Likewise, that metal will be simply separate. Metal will be simply separate. Now let's see the next one. Reductive ozonalysis. I told you there is one more method which requires rigorous practice. This is one of them. Okay. Calcium salts of carboxylic acid is very important. Reductive ozonalysis is very important and requires separate practice. Okay. Special practice is required. In this one, what happens, whether it is ketone or aldehyde, it will form a ozonide. What it will form? Ozonide. Okay. So this is a ozonide. Understood? So after that, what it will do? This will break this like this. So this will be a ketone or aldehyde. This will be ketone or aldehyde. So this practice I will tell you with the tricks. Okay? Because more chances of questions are there on these two topics. Dry distillation of calcium salts, reductive ozonalysis. Then by the hydrolysis of alkynes, KYNES, KYNES, alkynes, okay. It is also called Kuchervas reaction, okay. And here very simple, H2SO4 or 40% H2SO4. First it will form aldehyde. Sometimes it may undergo diatomerism. Diatomerism is just migration. Okay, so this is the acetaldehyde. Now this hydrogen will go here and double bond will come here. So it is going to form alcohol also. Understood? Acetylene gives acetaldehyde. Formaldehyde cannot be prepared by this method. We don't have a triple bond with one carbon atom. Can we have that? No. Okay. Next, hydroboration oxidation of terminal alkynes. Okay, this happened with one of our student. They have written HBO. So he asked, sir, what is HBO? Actually, HBO is not home box office. It is a TV channel also, but not that channel it is here. Hydroboration oxidation. And it should be terminal. Always multiple bond must be available on the first or last carbon. Because we want to prepare a aldehyde which always occurs on the last carbon only. Okay. So BH3 THF. What is THF? In structures also I told you a tetrahydrofuran. Okay. THF means tetrahydrofuran. Furan, tetrahydrofuran, oxane. This we have studied. Okay. In the ethers. In the where ethers. Commercial name we have studied. So next diacetyl borane is better. Okay. In the exam they will write DI, okay. So diacimide is better used in place of the B2H6 to avoid the complication due to addition across the diborane. Okay. Double bond is added, triple bond is added with the OH, then it undergoes rearrangement. So it will form what? Aldehyde. What is this? Aldehyde. Okay. This is the eighth method. Now let's see the next and final method. So alkaline hydrolysis of terminal gem dihalides. See, every word is very important. What is the importance? I am explaining. Terminal means on last. Gem means on same carbon. And how many? Two. Okay. See here, this is the carbon with halogen. And both halogens are on the last carbon only. Okay. So on that place, what you will find? Two OH group, but it is not permitted to have two OH group on the same carbon. So H2O will be eliminated and this will be double bond will be formed. Okay. So this method is not much used because aldehydes are affected by alkali and gem halides are usually prepared from carbonyl compounds. Okay, so this is about the preparation methods.